Hello.
Yes, sir.
Hmm. Can you hear me? Am I audible?
Yes, sir. Yes.
Okay. So, how many of you are present now?
Hmm. Huh?
Someone is having his or her microphone on. Please off. Okay. Uh, so today is our first class for design and analysis of algorithm. I think the paper code is 403, CS 403. Okay. So before that, I think that you have studied your data structure paper in your previous semester. Okay. So from there, we'll start to go for this design and analysis of algorithm paper. So before that, let us again recapitulate that what is an algorithm. Okay. So first thing is that we have to go for that what is an algorithm. So before that, let us first Microsoft Team this. Okay. So our topic is design and analysis of algorithm. The paper code is CS 403 and we are section X. Okay. Now, the first thing is that what is an algorithm? So I think all of you are aware that algorithm means a step-by-step procedure to accomplish a particular task and blah blah blah, all these. In other words, we can say that if we provide an input, so the process, if it produces and correct output, then we will say that it is an algorithm. Okay. Hello. Any difficulty?
No, sir.
Okay. So the algorithm in a single statement, or if you just copy the textbook sentences, then it is written as that it is a step-by-step procedure to accomplish a particular task. That's fine, no problem. But since we are in the higher semester, therefore, along with that, we should think about that. Is there any properties of an algorithm so that we can say that, okay, this step-by-step procedure, if it follows this property, then only we can say that it is an algorithm. Or in other side, we can say that, okay, an algorithm must have some properties and it has to be followed this. So the first of all is the input. Okay. Now, what is meant by an input? Suppose if I write in an algorithm that x equals to 5 and y equals to 7, then write z equals to x plus y. Should we say that x equals to 5 and y equals to 7 are input? No. So whenever we will talk about input, the user given inputs or user given data must be considered as the input. It should not be supplied within the algorithm or the program. I am not talking about the program. Please don't misunderstand between the algorithm and the program. So whenever we supply a value from the outside of the algorithm, then only we will consider this is an input. Otherwise, if it is supplied within the algorithm, it will not be considered as an input to the algorithm, right? So with respect to that, we can say that an algorithm may have 0 or more input. Someone can record this. I don't know whether it is getting recorded or not. Yes, it is getting recorded, right? So an algorithm may have 0 or more input, because in some cases, suppose we want to find, we want to write an algorithm to add 7 plus 8. So we can easily write that z equals to rate x equals to 7, y equals to 8 and z equals to x plus y, then print z. So this is also an algorithm, but here we are not considering any input from the user. So therefore here the input size is 0. Okay. Similarly, if I just want to get the print of some ASCII values, so ASCII values are already inside the computer, we will just go on printing print I equals to 65 or something like that. So just we will use the for loops, and if we go for printing the values, then there is no input, but still it is an algorithm. So therefore it may have 0 or more inputs. Okay. Similarly, an algorithm must have at least one output. Okay. Unlike input, if we say that, or like the input, if we say that it may have 0 or more in output, then it is a false sentence. Why? Because if there is 0 output, then why we should go for an algorithm? Okay. So there must be at least one output for an algorithm. Okay. The next is finiteness. Finiteness means an algorithm must terminate. This is a very important property of an algorithm. An algorithm must terminate after a finite number of iterations or a finite number of time. So now you can say that, sir, there are so many algorithms which are not terminating, just like operating system. Think about that. Operating system never terminates till you or is until you switch off your computer. Think about your mobiles, think about your laptops, think about your smartwatches and all others. If you do not switch off these gadgets, then uh, uh, for the infinite time the operating system will go on running. So how can we say that an algorithm must terminate after a finite number of time? So here lies the difference between an algorithm and a program. Okay. So operating system is not an algorithm only, it is a program. So this program is based on some algorithm. So there is a difference between an algorithm and a program. So a program may not terminate at all, but an algorithm must terminate after a finite number of iterations or time. So a program is a collection of algorithms. The algorithms may interact with each other and may go for infinite run, but each and individual algorithm must terminate after finite number of executions. I think you have got the point. If you have any doubt, so just at the end of the class again we can discuss this point. Okay. But the thing is that finiteness means after a finite number of iterations or finite number of time, every algorithm must terminate. Next, definiteness. Definiteness means each and every state must be unambiguous. Ambiguous. Okay. Each and every statement of an algorithm must be unambiguous. What is the meaning of unambiguousness? Say we are writing that if x equals to 0 or y equals to, sorry, y greater than 5 and z something xyz or something like that. Now the problem is, if x equals to 0 or y greater than 5 and z equals to 7, you see how many different statements x is 0 to 5 and equals to 7 and so we have to follow both the conditions here to make this print statement true, right? So this is statement 1. We can go for that. And another one can say that let x equals to 0 is a statement and or y greater than 5 and z less than 7 is another statement. So either this one is true or this one is true. X, Y, Z will get printed. Therefore, we are getting two different statements from a single sentence. So this is an ambiguous statement. So every algorithm should avoid this kind of ambiguous statements, and your algorithm, each and every statements of your algorithm must be unambiguous or definite. That means for a particular input, every statement should output an unique statement. Okay. So the output for each and every statement for a specific input must be unique. Clear? So this is definiteness. And the next and another important topic is, or the property is effectiveness. So effectiveness in terms of cost, obviously. So cost is cost means obviously any kind of cost. So here in computation we will consider the cost as per the time required, and another is memory. So our cost is calculated on the basis of time and memory. So effectiveness means every algorithm must be effective. That means the best one in with respect to time complexity and memory, that is space complexity. Okay. So these are the properties that to be followed by an algorithm. So later, whenever we will discuss some examples, then we can also talk about others. But our main focus is on effectiveness of an algorithm in our design and analysis of algorithm class. So we will try to design, or we will first analyze our algorithm which is given or which are known to us. We will first try find the time complexity of the algorithm, space complexity of the algorithm, that is known as analysis part, and if possible then we will go for finding the better one than this, and which is known as design part of this. That's why the topic is known as design and analysis of algorithm. Okay. So later I will give some example of this, that what is time complexity and what is space complexity. So before going to that, now what is the requirement of this finding effectiveness? Okay, just I'll give some example here, that why we should require to study this effectiveness of the algorithm. Let us think for finding what we can say. Let we have to find in larger elements from a given array of 2n number of elements. Let. Okay. So what is the problem? Problem is to find the n larger elements from a given set of 2n number of elements, or given array of 2n number of elements. Just for example, let us consider let 5, 8, 7, 6, 4, 2, 9, and let 1. So n is here equals to 4, therefore 2n, we are having 8 number of elements. We have to find out n larger elements from the list. N larger means here the larger is 9, then 8, then 7, then 6. So our output is 6, not only that, 8, 7, 6 and 9. This is our output. So if we have to find out the n larger elements from the given list, obviously the first thing that we should keep in mind, that okay sir, the solution will be that you first sort the list, and if it is in ascending order, just you take the last 4 values. Okay. So if we go for finding n larger elements from the 2n number of elements, the first algorithm that should come in our mind is that we should sort the element, all the elements, and take the last 4 values. Okay. But since you have the idea of sorting like merge sort, quick sort, bubble sort, insertion sort, all these, you have found the best algorithm exhibits n log n time complexity. Okay, forget about what is the meaning of this. Let this is a value. So if we have 2n number of elements, and if we have to go for sorting this, we require 2n log 2n number of comparisons. Okay, or the time complexity is this, it may be theta or O, or later I will come. So the time complexity will be 2n log 2n. The question is that, is it possible to find the same answer with less than this time? Okay, which will be the value is less than this, so it will be greater. So is it possible to find a better algorithm which will take less time than 2n log 2n? Okay, let us check that whether it is possible or not. Okay. So first for this, we will divide the list into two equal halves. So n and n. Okay. So you sort these elements in ascending order or maybe in descending order, anything. So let us consider we are sorting this n number of elements in ascending order. Therefore, we will get 5, 6, 7, 8. And the another half in descending order. So 9, then 4, then 2, then 1. So what are we doing? What we are doing? We are considering n and n to have. We are applying sorting here and also here, but here we are increasing order. Here we are doing in decreasing order. Okay. So the time complexity is n log n plus n log n. So we can say that 2n log n. Then we are comparing the first element with the first element of this and we are selecting the maximum among these two. So what we will get if we compare 5 and 9, we will get 9 here as the output. Okay, so let us write here 9. Then we are comparing these two elements and selecting the higher one, larger one. So we will get 6. Then let us compare between these two 7 and 2, we will get 7 here. Let us compare these two, we will get 8 here. Okay. So let us check. We have got 4 larger elements 9, 6, 7, 8, which is the our desired output. Okay. Now what is the time complexity? 2n log 2n to sort these elements plus n number of comparison to compare between these two sets. And this is much less than 2n log n plus n. Okay, 2n plus log n is less than 2n log 2n. You can check with any value. Okay, so we require to study this design and analysis of algorithm to find the better algorithm always. Okay, similarly, let us go for one example for space complexity. So how we can go for finding or how we can calculate the space complexity or how we can take care of the space complexity analysis. So we have to multiply two 3 cross 3 matrices. And we have to store the output in a matrix. Okay. So if it is a 3 cross 3, then how many memory space we require? We require 9 plus 9 18 plus 9 27. So 27 memory space we require to multiply two 3 cross 3 matrices and to store the result in a 3 cross 3 matrix. Okay. So you can consider this as any value n cross n or something, m cross n or n cross 3, anything. So here for the simplicity, I am considering the square matrices for the simplicity only, nothing else. Now the question is it possible to solve the problem, that is to multiply two matrices and to store the result in a matrix by less than 27 number of memory space or not? The question is that is it possible to do the same thing with the less number of memory space than 27 or not? Okay. So in the first impression, we can think that yes, it is not possible. Someone may say that yes, it is possible. But the thing is that let us try that whether it is possible or not. Then only we will be able to understand the necessity of studying this paper. Okay. Now, what is the algorithm to multiply two matrices? Just we are considering this 3 cross 3 again. Okay. So the algorithm is that we multiply this element with this one, the first row second element with the second row first element, the first row third element with the third row first element. We multiply all these values here and add this. Okay, to get the first element of the resultant matrix. Okay. So we multiply these three elements with the first column to get this value. Then what we do? first row, second column to get this value. First row, third column to get this value. Okay, let us consider these are not considering, but think about that we are having this type of data structures, but we are not using this one. Okay. Now after that, after calculating the first row of the resultant matrix, do we ever need the elements of the first row of the first matrix A? Let this is A and this is B. Think about that. After finding the elements of the first row of the resultant matrix, do we ever require the elements of the first row of the first matrix? No, we don't require this, because in the next iteration what we will do? Second row, first column, second row, second column, second row, third column, and so on. Okay, so we do not require these elements. Hence, we can reuse this memory spaces. So what we will do? We will just copy this value here. Okay, we will just copy this value here and we can reuse these memory spaces. So later what we can do? Second row, first column, second row, second column, second row, third column. We will get the second row of the resultant matrix and we will copy all the values in the second row of the first matrix. Similarly for third row, first column, third row, second column, third row, third column, and we can copy all these values and we can store it here. Now see, just A will becomes the resultant matrix or the output matrix. So what is the memory space that we require? 9 plus 9, 18 plus 3. So it is 21. So by the use of 21, the values or the output matrix. Okay. So therefore, every time we have to analyze our algorithm for time complexity and space complexity to find out the better algorithms. Right? Have you understood?
Yes, sir.
Okay. Are you getting any interest to learn this subject?
Yes, sir.
Okay.
Yes, sir.
So very good. Because if you do not get any interest to learn the subject, then in this pandemic situation, see, I cannot see your faces, right? This is very pathetic for a teacher like me. So if I do not get the chance to see the faces of my students, so really it is very pathetic for me. Still, we have to cope up with the situation. So whenever you feel that you are not getting anything of the class, you can ask your questions, or if you feel that this is not the right time, then you can send message to my WhatsApp that sir, I have not understood this particular part. So I will try to again explain that part. Okay, so please don't hesitate to ask the questions and don't hesitate to say that you have, right? Okay. So next, how to, so here we have got that how to, or what is the requirement or what is the necessity of studying this paper, design and analysis of algorithm. But the question is that how to find the time complexity or the space complexity of an algorithm. Is there any model or is there any method? Yes. Generally, we follow a model which is known as random access machine. Okay, this is not random access memory. That is also known as RAM. But here, the model to count the time complexity or the computation complexity is known as RAM model, or which is known as random access machine. So random access machine is just a virtual concept where we consider an assignment statement as, or the time complexity of an assignment statement is considered as 1, or in other words we can say that constant time. Okay, in other words we can consider that the time complexity of an assignment statement is 1 or constant. Most of the cases we write big O of 1 or theta of 1 or something like that. But in general, let us consider now for the time being that we will consider the numerical value 1 for any assignment statement. I will give some example later. If else statement. So we know if else block is like this. If is containing some assignment statement or maybe containing some another blocks, something like that. So there are if and else block. Okay. So if it is containing some assignment statements or if statements or loop, so it must have some time complexity of this block, and also for this block we are having some time complexity. Now if we have to go for finding the maximum time complexity, we will choose the maximum among these two. If we have to go for finding the minimum, then we have to choose the minimum among these two. So that means for an if else statement, we have to find out the time complexity of the if block and also the else block. If we have to go for maximum, then we have to choose maximum between these two. If we have to go for finding the minimum time complexity, then we have to go for choosing the minimum among these two. Okay. So if there are any if else statement, we have to find out the time complexity of both the block, and we have to choose if this condition is true, this one will be executed. If the condition is false, this one will be executed. So either one will be executed. Okay. Next, loop. If your algorithm is containing any loop, then the time complexity of the loop block will be the time complexity of the block multiplied the number of executions of the loop. So if I write for time complexity of the whole block will be the time complexity of this block multiplied by n number of executions. So that will be the total time complexity of the loop. Function calling. Function calling is that suppose f1 is calling a function f2. f2 is calling another function say f3, and f3 is a standalone function which is not calling any other function. So if we have to find the time complexity of f1, then first we will search for f2, but here f2 is calling the function f3. So we will start to calculate the time complexity of f3, then f2, then f1. Okay. So it will be a bottom up approach. So for any function calling statement, we will start to calculate the time complexity of the function which is not calling any other function. Next, we will find the time complexity of those functions which are calling f3 like, that is, which are not calling any other functions. Then next one, and so on. In this way, we can calculate the time complexity of a function calling statement. Okay. So let us go for one example. So then it will be clear. So this is an example of bubble sort algorithm. All of you are habituated with this coding and pseudo code. But again, please don't mix up between an algorithm and a program. These two are very different. Okay. Here I have written like this print array. I don't know whether it is a particular comment of any programming language or not, but still here in this course we will try to write the pseudo codes, not the programs. Okay. And we have to find the time complexity of this algorithm. Okay, in terms of the total complexity, not the asymptotic notations. So here you see uh, this swap has been called by this bubble sort algorithm. Okay. Similarly, this main is calling this bubble sort. So if we start to find the time complexity of main, then first we have to check which one we are calling. We are calling a function bubble sort and we are calling a function print array. So whenever we are calling a function bubble sort, we have to check that whether what is the time complexity of this. Whenever we will go for finding this algorithm, then we say that we find that there is a function calling which is known as swap. So let us start from this function which is not calling any other function. So here you see int temp equals to this is an assignment statement. So we are considering this is 1. Similarly, this is also assignment statement. This one is also assignment statement. So the time complexity of swap function is 3. Okay. Next, there is another function print array which is not calling any other function. So here int I, we are not considering the declarating or declaration statement. Therefore, we don't have to go for finding the time complexity of any declaring or declaration statement. So forget about this. Then for I equals to size. So here if we consider n, so therefore it will execute for n times and count. That means we are doing some assignment statement C out array, that is we are printing. So you can consider this as 1. So therefore it is n plus 1 and at the end it is 1. So the time complexity of print array is n plus 1. Then we are calling bubble sort. Here you see again this we don't require to calculate. Now for I equals to 1 to n minus 1. So let us consider this is n minus 1. N only. Okay. Similarly for j equals to n I minus 1 minus 1. So at most it will execute for n times at most. If array is less than this, so conditional checking is 1. We can omit also this and swap this. Swap again considering 3. So 3. So here 3 plus 1, 4, and it will execute for n cross n. So the time complexity of this bubble sort is function is 4n square. Hope you have understood. Now we are finding the time complexity of the main. So here integer array is a declaration statement. So forget about this. Int n equals to size of this. So we are assigning some value to the this variable n. So it is 1. We are calling the function bubble sort, which already we have found that it is 4n square. So the time complexity of the main function, this is 1 for this statement. Bubble sort is plus 4. C out sorted array is 1. Then print array is n plus 1. Return 0 is again we can say 1. We can also omit this value. So if we have to calculate the time complexity of bubble sort, then the time complexity we can write as 4n square plus n plus 1, 2, 3, 4, 4. Okay. So hope you have understood that how to calculate the computing time by using RAM model. RAM is random access machine. Okay, right? So, but the thing is that in any book, the whatever the book you have followed during your data structure course, so you have found that the time complexity is always written like this. But the time complexity of bubble sort is order of n square, not 4n square plus n plus 4. Now, what is the reason? Okay, so that is the next day we will discuss about that how we are getting the value from 4n square plus n plus 4 equals to this. But before that, today we will go for discussing what is the meaning of time complexity, because most of the people do some mistake that time complexity analysis means time complexity analysis means to find the execution time of an program, which is a wrong thing. Time complexity analysis is not to find the execution time of a program. Rather, we can say that it is a comparison between more than one algorithm. So when or if we have to compare between two or more algorithms, then we need to go for analyzing the time complexity. Just like say bubble sort, we can easily sort n number of elements by using bubble sort. Then if we say that what is the require of going for merge sort, because you can say that no sir, the time complexity of bubble sort is order of n square, the time complexity of merge sort is theta of n log n. Then we have quick sort, which is another very good algorithm. This is also taking n log n. Now what are the meaning of this? Is it? I have asked so many questions to a lot of students which are coming for MTech courses and others, and also pass out BTech students, that if we have 10 number of elements to sort, and if we use the bubble sort, then what will be the time complexity? Everyone say that it is 100, but which is false. There is no concept like 100. What is 100? 100 unit? No. There is nothing like concept of unit for time complexity. Order of 100 means constant time. So when the number of elements or the input size is fixed, when the input size is fixed, every algorithm takes the constant time for execution. Now you can say that, sir, you are making us confused. Yes. You see, here everything we are discussing for n is variable, number one. And next, n is very large, that tends to infinity. Now the thing is that, think about this this one, that let you are following an algorithm which is order of n. Forget about this O and what is written. Let us consider this is a polynomial, not O. Let a polynomial of n. So if we plot the polynomial n, what we will get? We may get a straight line here. So that means if you go for finding the slope, it is a constant. So constantly increasing when n is tends to infinity, increasing. So this is say Tn, time complexity, and this is n. Now if it is n log n, then you will find that after few times it is increasing like this. So that means whenever you are increasing the n, after few execution it will go for increasing in this way. If it is n square, okay, and if it is exponential, say the time complexity is a to the power n something, so immediately it will go for increasing just like parallel to y-axis, so high value. So therefore whenever we are talking about the time complexity of an algorithm, say n, so we can say that whenever n the input size is increasing, the execution time taken by the algorithm will increase in this by following this path. When the time complexity is n log n, as we increase the n, the time complexity or the execution time will increase by following this curve. Similarly for n square, similarly for a to the power n. So please don't get confused by the execution time, actual execution time, and the time what I have said, uh, time complexity analysis. Okay, these two are related, but time complexity analysis does not mean to find the actual execution time, rather it is to compare between algorithms. Okay, right, I think the time is over. Do you have any other class now? Seer, Karan?
We might have another class today, but
You are
let
not
me
sure.
let me check and see, sir.
Uh-huh.
From 3:45 we have theory of computation.
Sorry, Papi. That is a very difficult topic. So you have to free your brain. Or can I continue for another 15 minutes?
Uh, yes, sir, you can continue.
Yes, sir, or no, sir? Discuss among yourself. Are you getting any interest, or I can stop and next day again we can discuss anything that you want?
So actually, Section X is again having DS extra classes from 4:30. So like
Oh,
it's just about the data, sir, nothing else. Like I think we could have continued, but I'm not sure, like,
Another,
fine.
so
Yes,
I
how
can
many days?
continue for another 15 minutes. Hello, can I continue for another 15 minutes?
Yes, sir. Yes, sir.
Okay, okay, okay. Chalo. So, do you have any questions from the whatever we have discussed till now?
So one thing, sir,
Mhm.
you wrote that quicksort takes n log n time, but in worst case it takes a big of n square, I think.
I will go on that. Don't worry. But in general, I have written the average case time complexity is n log n.
Acha, okay.
Okay, okay. I'll discuss that. What is best case and worst case. Till now, have you understood?
Yes, sir.
Okay. Am I going a little faster, or is it okay that the speed is okay for you?
Yes, sir.
Okay.
Yes,
So
sir.
now, okay, thank you. So now, so what we did, we have first find out that how to calculate or how to compute the time complexity by following the random access machine model, which is known as RAM model. Then we have gone through one example and we have found that the time complexity is like a polynomial, okay, like 4n square plus n plus 4 for this bubble sort. Now, there are three different kinds of situations. For whenever we calculate the time complexity, we may face three different situations. One is that whatever we are getting is the best case. Best case means uh, the minimum time, okay, that we require to execute, and we can execute our algorithm with this much of time, okay, at least this much of time. So let us consider for quicksort. What is the meaning of best case? So actually, okay, before that, let us going for before the best case, let us go for worst case. That will be a beautiful explanation for worst case time complexity. So how bubble sort works? Bubble sort works like this, that we are having n number of elements, and we consider either the first element or the last element as the pivot element. Here I have written the, for your recapitulations, you can just check this, that quicksort algorithm is written here. So if we consider this as the pivot element, we go for some comparison within these elements, and we make a partition like this where the pivot element is being placed here. All the left hand side elements are less than this pivot element, all the right hand side are greater than pivot element. We are considering all are distinct for the sake of simplicity. Okay. So all the elements less than the pivot elements are in the left hand side, all the elements are in the right hand side which are greater than this. Now if all the values are in sorted order, then what will happen? Say suppose 7 is our pivot element. So 7 will be placed always here, and your left hand side is containing n minus 1 number of elements, right? And the right hand side is containing single element. So if you go on calculating this value, you will find that n minus 1, n minus 2 and so on up to 1. So if you take the plus of all these, you will get a series. Oh, you will get a series, and that will give you the time complexity as a polynomial of n square. I am not writing order of or something. It will be a polynomial of n square. So worst case means, I think you have heard the situation that if we supply an already sorted array to the quicksort, it will exhibit worst case time complexity. So worst case means the maximum time to be taken by the algorithm. Okay. So the maximum time taken by the algorithm is known as worst case time complexity. So it will not take much or more than this value. That is worst case. So I can say that suppose if you have to sleep, suppose I want to sleep in a room and the cot size is this one. Okay, my size is say 6 into 6 cross say 3 or something like this. So if you provide me this much of space, obviously it will be sufficient. Okay, so worst case means at most this much of time is required to execute this algorithm. So in this case of quick sort, order of n square, that means a polynomial of n square is sufficient for the execution of bubble sort. Now what is best case? Best case in this situation is that if always your algorithm divide the input as n by 2 and n by 2. Okay, later we have the full or a full chapter on this quick sort or the analysis of quick sort. At that time again I will discuss it in details, but for the time being, to get just a concept of what is worst case, best case and average case, I have considered this value. Now if we go for dividing the array always n by 2 into n by 2, then it will exhibit best case, because I think all of you are having the sorry. So Tn will be equals to 2t n by 2 plus something like that n. Forget about what is the meaning of this. Those who have studied discrete mathematics, you can find this is very familiar to you, because this is a recurrence relations, and we can write that the time complexity for n is equals to 2 equal half of n by 2. So again, please don't think that all these are very complicated. Forget about everything. Let our algorithm divide the input always into 2 equal halves n by 2 n by 2. So if we go on finding this, so we will get a tree like this, n by 2, then again n by 4, n by 4, this is n by 4 and so on. So you can find that the length or the height of the tree is log of n, and the time complexity for this is n log n. So what is the meaning of best case? Best case means at least we require this much of time to execute the quick sort. If someone say that is it possible to execute quick sort with the less time than n log n, we will say that no, it is not possible. Why? Because we know the best case time complexity is n log n, so we require at least n log n to execute the quick sort. Now think about a situation that we are saying if our algorithm always divide our input into n by 2, then we are getting best case. If we supply a sorted array through the quick sort, then it will exhibits worst case. Now the question is that if our algorithm depends upon the nature of the input, then how we can say that we are finding the time complexity in a independent platform, right? So whatever we should do, it should be independent of the platform. Suppose we are executing quick sort in my laptop, and some of you are executing this in supercomputer. Obviously the execution time will be less, very less in supercomputer, but you cannot say that the time complexity of bubble sort in supercomputer is very less than the time complexity of quick sort in a laptop, personal computer. No, this is completely wrong information. Okay, so whenever we are going to find the time complexity, it is independent of platform, and our platform is random access machine, where we calculate the time complexity in this way that we have discussed. So here you see that the best case is dependent upon the nature of the input, worst case is also dependent upon the nature of the input. So we cannot say that these two are independent of the platform. So then sometimes we require the average case or the probabilistic, or we can say the expected running time. Okay. Later again you will find all these terms during our discussions. So average case means what we will do, we will just consider an input which are not defined previously. So that means we will not say that always we will get the sorted array, we will not say that always our input will be divided into n by 2, n by 2, right? So there are some methods to get this average case time complexity, which is known as randomized algorithm. Again, we are having one topic on this randomized, later we will discuss. But an algorithm may have three different kinds of scenarios. One is best case. Best case means at most we require this much of time complexity. Worst case, at least we require this much of time complexity. Average case is independent of the nature of the platform, that means input. Okay, or we can say that it is a probabilistic approach to find the time complexity, or we can say the expected running time of an algorithm. Okay, so up to for today, we will stop here. If you have any questions, please you can ask. Hello. Hello.
So no question.
Do you have any questions? No. I think there is some connection problem. Can you hear me, anyone?
Yes, sir.
Yes, sir. Yes.
Okay.
No question.
No
No
question.
question, sir. No question.
Okay, okay. So we have the next class on Thursday, right? From 3 to 3:45 most probably. Okay, I will check and send you the link. Okay.
Yes, sir.
Okay, thank you very much. Chalo.